Okay, so in this video, we will talk about how to factor more quadratics, but now we are not going to restrict that first x squared term to have a 1 in the front of it. We're going to look at how to factor when we have a quadratic that has a number in front of the x squared that is not 1, but is also not negative. So there are two approaches, and I'm going to show you both of them, but I really encourage you to stick with the second one unless you already know the other method and you're totally comfortable with it. So the two approaches are guess and check, and then also what's called the AC method. So just to, there we go. So to kind of contrast the two methods here, I'm going to go through the same polynomial and factor it just in both of the ways. So let's look at 2x squared plus 13x plus 6. And first we'll do it by guess and check. Okay, so if we wanted to factor a quadratic, then the way that it would factor would be as two linear terms, meaning to the first, x to the first. And in order to get the 2x squared here, I mean, we've got to have x and x as the first terms in each of the linear pieces, but one of them has to be a 2x now, and the other one has to be an x, right? So that when you multiply the first terms together, you end up with the 2x squared. Okay, so let's just write that down here, right? So the 2x and the x have to be here so that when you multiply them, we get 2x squared. Now the question is figuring out what the other things are. So like what goes in this box? And then also what goes in this box. And it's not so simple as to just figure out what multiplies to 6 and adds to 13, because of this 2x here that's going to not only get multiplied to the x here, but also to this piece. And so this piece, when we get the middle term, is not just going to be this number times x, it'll be this number times 2x. Okay, so this makes this a little bit trickier. All right, so to write down what I just said, the boxes, they still must multiply to positive 6. But now it matters like where we put those numbers. Like before it didn't matter because both of the first pieces were x, but now it does make a difference. So, but now it matters where each of those factors of 6 go. Since one factor has a 2x and the other has a 1x. I don't know why there's such a lag here. I'm sorry about that. But okay, so the guess and check method is literally what it sounds like. You just take all of your possibilities and see which one works out. So here are the options. Okay, so we know it's got to look like 2x and x. Now we know that those numbers that we're going to stick in there, they have to multiply to 6. So maybe we've got 2 and 3, and maybe they are in this orientation. Okay, so let's try this. So if we multiply this out, we're going to, so the first term gives us 2x times x, so that's 2x squared. Okay, then we've got the 2x times 3, so that's plus 6x. Then we've got 2 times x, so that's plus 2x. Then we have got 2 times 3, and so that's plus 6. And so when you simplify that, that gives you 2x squared plus 8x plus 6. And that is not what we were looking for, right? We need a 12 in the middle, or sorry, a 13 in the middle. All right, so maybe the 3 and the 2 get switched around. So maybe instead we've got 2x plus 3 times x plus 2. So let's multiply that out and see. All right, so 2x cubed, I'm sorry, what did I write that for? 2x squared is our first term. Then we've got plus 4x. Then we'll have plus 3x and then plus 6. Okay, so that's 2x squared plus 7x plus 6. And again, that's not what we were looking for. Okay, so 2 and 3 aren't going to work. So the other factors of 6 are 1 and 6. So let's play with those. So maybe we try 2x plus 6 and x plus 1. Okay, multiplying that out, we get 2x squared plus 2x plus 6x plus 6. And that gives us 2x squared plus 8x plus 6. And again, that's not what we were looking for. All right, so let's hope that this last one works. So that would just be switching the 6 and the 1 around. Okay, let's see. So that's 2x squared plus 12x plus 1x plus 6. And, oh good, so that looks like we've got our 13x where we wanted it. Am I stuck here on this? Oh, okay. So that is great. So here is the factored form that we were looking for. All right, if you notice, right, so like the 2x squareds and the 6, they're the same. Sorry, I'm waiting for this to catch up. They're the same in both, in all 4 of these situations. However, the middle pieces are what's changing around, right? And it's affected by where we put those numbers. So I don't know if you guys have like learned this before in this way. I think that this is tedious, especially if you have a number like the 6 here. Come on, like this 6 here that has a lot of factors. Like we just had 2 and 3, and then we had 6 and 1, and every set of factors could be, you know, like switched around. And so you get 2 things to try for each one. And on top of that, maybe the 2x squared here, maybe it's something like, you know, maybe if it's 4x squared, maybe you have a 2x and a 2x, or maybe you have a 4x and a 1x. And so that's even more options to try. So I would say this method is tedious, and I'm not going to use it in class, but you can if you'd like. I'm going to show you another method that will always work no matter what. And it's just a process that you have to kind of understand and follow. Okay, so this method is called the AC method. So the steps to follow the AC method, I'm going to write them down as we go through this example. So the same polynomial we're going to factor, and I'll show you we get the same thing. The first thing you want to do is, if possible, factor out a GCF. And that's not, that doesn't apply to our polynomial here. So we will just not, we don't have to do anything for that step. Okay, the second thing is to, so make sure that this only works for ax squared plus bx plus c, where the a is not 1 and it's not negative. What you're going to want to look for is 2 numbers that multiply not to just c this time, but to ac, so a times c, hence the AC method, and add up to b. Then there's one little extra step here. It's not just write those numbers down, like we did with reverse foiling. Then you need to split up the middle term, so the bx term, using the numbers found in step 2, and then you factor by grouping. And I'll show you exactly what each of these things mean by going through this example. Okay, so step number 1, we don't have anything to do there. right, for step number 2, we need to figure out what a times c is. So, right, it's a x squared plus bx plus c, right? So a is 2, b is 13, and c is 6. So we're going to take a, which is 2, and c, which is 6, and multiply them together. So that gives us 12. Okay, now we're looking for factors of 12. So two numbers that multiply to 12, but add up to b, which is 13. Okay, so you can list them all out if you want. I mean, we've got 1 and 12. We've got -1 and -12. We've got 2 and 6, -2, -6, 3 and 4, -3, -4. Right, the ones that add, the pair that adds up to positive 13 is 1 and 12. Okay, so that's step 2. Now step 3 is to take the middle term, the bx term, so the 13x, take that term and split it up using the numbers we found in step 2, so 1 and 12. So you're going to split up the 13x into 1x plus 12x. And then the 2x squared and the 6 just stay. Maybe I should make my arrows clearer here. So let's do, so it's 13x is the same as 1x plus 12x. And once you do that, then you factor by grouping. So we've written a thing that has 4 terms. So we're going to group here and group here and look for a GCF. So the first group has a GCF of an x, and the second group has a GCF of a 6. Okay, and so we're going to take out each of those GCFs. So here we've got x times 2x plus 1. Then we've got plus. The GCF here is a 6, so that'll be 6 times 2x plus 1. Again, here's just the equivalent of the first group. Here's the equivalent of the second group. Okay, and then we've got a GCF here of the overall of a 2x plus 1, and so we can take that out. And what we will have left is x and then plus 6. Okay, and then if we look back to the guess and check method that we tried on the same polynomial, the same quadratic, we got the same thing, right? We still got 2x plus 1, x plus 6, I hope so. Yep, right here. It just, I don't know, I think this way, at least I know that it's going to lead me to the correct answer. Whereas with guess and check, you know, maybe I'll get it the first try and maybe I'll get it like the 8th time that we guess. And so I don't know, I like to try to do this method over the guess and check. But like I said, if you like the guess and check, it's totally fine. All right, so, and the rest of this section, we're just going to practice this method. So I'm going to go through just a few examples, and then I'd encourage you to look at the notes and go through and try the rest of them on your own. So example number 1 here, you know, we need this kind of method because in front of the x squared, we don't have a 1, we have another number. All right, it's already positive. We look at, see if there's a GCF. So we've got a 2, a 7, and a -4. I don't think there's any numbers we can take out here. So the next thing that we want to do is form the product a times c. Okay, so it's 2 times -4. You want to group the negative sign with the c, so it's -8. All right, so now I'm looking for 2 numbers that multiply to -8 but add up to +7. All right, so that's, you know, 1 and -8. We've got -1 and +8. And I think that's our winner right there. Okay, so then you take the 7x and we're going to split that term up into, I should say, -1x and then plus 8x. And then factor by grouping. So here and here we've got 2 groups. GCF in group number 1 is just x. GCF in group number 2 is a 4. Okay, so taking out the GCFs, we've got x times 2x minus 1. Then we've got plus take out the GCF of 4, we've got 2x minus 1. Okay, then we take out this GCF of 2x minus 1, and what we are left with is x plus 4. And there we go, it's completely factored. We've got two linear terms here, and we have factored this quadratic. All right, example number 2 is 8x squared minus 14x plus 5. So look for a GCF first. I don't see any, so let's go ahead and, right, we've got a number in front of the x squared here. It is not 1, but it is positive, so that's good. And so we should go ahead and use the AC method. So let's find a times c. So that's 8 times 5, so it's 40. Okay, now we need factors of 40 that add up to negative 14. Okay, so, I don't know, we've got 1 and 40 and negative 1 and negative 40. Well, they're 39 apart, so that's not going to help us. We've got 2 and 20, so 2 and 20, negative 2, negative 20. I don't think that works. We've got 4 and 10, negative 4, negative 10. I think that works, right? Negative 4, negative 10 will add up to negative 14. So let's split up our negative 14x into minus 4x and minus 10x. Right, then we look at the two groups of 2 and we find our GCF. So in the first group, we could take out a 4x. And in the second group, remember when there's a negative in the front of the second group's term in the beginning, you want to take out a negative number. So here, let's take out a negative 5. Okay, so this will look like 4x times 2x minus 1. Then we're going to do minus 5 times. Now the signs are going to change here, so we'll have positive 2x and then minus 1. Remember, it's like dividing by negative 5 on both of the terms here and here. Okay, so then we can take out the greatest common factor overall of 2x minus 1 again. Happens to be the same as the previous example. And so then we are left with a 4x minus 5. And there's our factored form for that quadratic. All right, example number 3 is 6x squared minus 2x minus 20. Actually, let's move on. Sorry, let's skip that and move on to example number 4. So this is y's, but it's okay. Same thing works. And if you're looking at this, I mean, it's y to the 4th, right? But if you continue looking on, we've got y cubed and y squared, right? Cubed and y squared. And so we can factor out a y squared from all of the terms. And on top of that, we have 18, 21, and 60. And those are all divisible by 3. So we can factor out an overall greatest common factor of a 3y squared. Okay, what we're going to be left with in the beginning term, the first term will be 6y to the second, then plus 7y to the first, and then minus 20. Okay, now we've got a quadratic here, and it has a coefficient in front of the leading term that is greater than 1. And so we want to use our AC method. So let us take a times c. That is 6 times negative 20, and so that's negative 120. Okay, we need two factors of negative 120 that add up to 7. This one's tough. Let's see. Well, we can have well, I don't know, we could start with 2, I guess. I don't think that's going to work though. We could do 2 and negative, what would that be? Negative 60. That's how we found this. That doesn't work. So negative 2 and positive 60 won't work either. We could have, so 4, that would be 30, but negative 30, or negative 4 and positive 30. That's not going to work either. They need to be closer together in order to, the difference here is too large. So what is 5 going into 120 would be, well, 5 goes into 120 times. 20 more would be 4, so it'd be 24. So 5 and 24. I think that's still, the difference is too large. How about 10 and 12? I think the difference is too small, so we've got to have something in between. 6 and 20. I don't think that works either. Nope, that'll give us a difference of 14. What's going on here? What else do we need? We need a smaller difference, so something between 6 and 10. Does 8 go into 120? Let's see, 120 divided by 8. So 8 goes into 80 10 times, and then we got 40 more to get to 120. 8 goes into that 5 times. Okay, so 8 times 15, those are 7 apart. So I think, so we need positive 7, so it'll be -8 and positive 15. Okay, so we don't want to lose this 3y squared here. So keep it, coming down. So this will be 6y squared. We'll have -8y plus 15y and then -20, right? We're splitting up this 7y into these two guys here. All right, now group. So here we've got 6y squared and 8y. So the GCF here will be, 2y? Okay, this group will have a GCF of 5. Okay, so what have we got here? We're going to take out a 2y. We will have a 3y left and then -4. Here we're going to take out a 5. We'll have a 3y left and then -4. Okay, keep this 3y squared just hanging out in the front. We will have a 3y -4 to factor out of those two terms in the outer parentheses. Kind of hard to see right in these pink ones here. So I guess we could even put those in here. And then we will have a 2y plus 5 left over when we factor out the 3y -4. Those pink parentheses aren't really necessary. I'm just trying to visually show you like where they came from. Okay, so I've got a few more down here, but I'd like to leave those for you to work on for some practice, and I will put up the solutions to these if you'd like to look at them in the notes.